Hi, this is Dr. J. Vikas Paul. In this session, we'll discuss about the analyzing the frame by using stiffness method for no sinking case. So no sinking is there here. So you can see the continuous beam here A, B, C, D, E, and this is B. At B you have hinged support, at C roller support, at D you have roller support, and point loads are there and spans are shown. I, 2I values are given here. So in stiffness method, the first step is to calculate kinematic indeterminacy. So degree of freedom is 5. So how? So here you will have 1 degree of freedom moment. Here you will have 2 degrees of freedom horizontal and moment. Here you will have horizontal movement and moment. 5. So 1 plus 2 plus 2 5. But practically due to the hinge at B, there will be no horizontal movement at C and D. So we can cancel those horizontal movements at C and D. Therefore degree of kinematic indeterminacy is 3. 1 here moment theta B, theta C and theta B. Theta B, theta C and theta D are 3 unknowns. Therefore K is 3 by 3 matrix. So that means K we will get as like this 3 by 3 matrix, 3 by 3. Next step 2 is calculating fixed end moments. So take this B, C and D. Here we need to calculate the fixed end moments. MFBC, MFCB, MFCD, MFDC. Right. So here we know for point load the formula. This is point load at center. This is eccentric point load. So these are the formulas you can substitute and you can find the fixed end moments. Then step 3, assign the coordinates and find the restraining forces. Yeah, before going to that, let us discuss here. If there is, suppose in the problem, if any sinking is given, suppose if he says at C there is some delta sinking value, sinking so and so 8 mm, 8 meter, sorry 8 mm, so 0.008 meter. Then what we have to do? So in MFBC, along with this, we need to add 6EI delta by L square. Here also MFCB also we need to add 6EI delta by L square. But as for this PC, as there is sinking at right side, so right side support is sinking downwards, right side is downward and left side is upward. Therefore we will, as per the sign conventions, we will take minus 6EI delta by L square. So plus of minus 6EI delta by L square. Here also plus of minus 6EI delta by L square. MFCD, here also we will get the extra moment, but here plus 6EI delta by L square plus 6EI delta by L square we will get if there is sinking at C, like that. So in this problem there is no sinking, so as it is we can write. So next step is assigning the coordinates and finding the restraining forces. So 1, 2, 3 coordinates are assigned, and now we need to find restraining forces. We gave coordinates 1, 2, 3 where the unknowns are there, and we have written the fixed moment values 250, 250, minus 180 and minus 120 we have written here. Now how to calculate P1, P2, P3, or we can also say it as delta DL1, delta DL2, delta L3. So algebraic sum of all the fixed end moments at that particular joint. So delta DL1 equal to, so at 1 how many fixed end moments are there? How many fixed end moments are there at first coordinate? Only one, minus 250. So minus 250 MFBC. Next delta DL2, that means at 2 algebraic sum of all this, that means MFCB plus MFCD, 250 minus 180. MFCB plus MFCD, 250 minus 180 is 70. Then finally delta DL3 is nothing but at the third coordinate how many moments we have? Only one, 120. So MDC is 120. Next step is to calculate the stiffness matrix, K equal to K11, K12, K13, all this. So here how to find K11, K12, K13? To find K11, K12, K13, we need to apply the unit rotation at B, at the first coordinate, that means at B. So due to this B there will be some reflection here. So at this point it is K11, K12, K13. due to the unit moment, so the stiffness value here is 4EI by LBC. 4EI by LBC. Next here it will be 2EI by LCB. So here the value is 4EI by LBC, 2EI by LBC. Next, so here there is no effect, therefore K13 equal to 0. Next, to find K21, K22, K23, we need to apply unit rotation at C. At C you need to apply the unit rotation. Okay, due to this unit rotation, the value here for BC, the formula here will be K22 will be 4EI by LBC, and here it will be 2EI by LBC. For this span it will be, here it will be 4EI by LCD, here it will be 2EI by LCD. Therefore here you will have two values, K values, so sum it. This is K21, K22, K23. Next, to find K31, K32, K33, we need to apply unit rotation at this joint D. So if we apply, you will get like this. Here you will get 4EI by LCD. Here you will get 2EI by LCD. Here 0. In this way, we can find the stiffness matrix values. Yeah. So in the next step, we are using the equation delta DL plus KD equal to delta D. We can find unknowns. What are the unknowns? Theta B, theta C, and theta D. So now what is delta DL? This is also written as P. Okay, P plus KD equal to delta D also we can write. Okay, delta DL means delta DL1, delta DL2, delta DL3. So what are these values? These are nothing but restraining forces which we have calculated in step 3. In step 3 we have calculated restraining forces. Now these are DL1, delta DL1, delta DL2, delta DL3. Next, K into D. K means stiffness matrix values. Already we have calculated here. Substitute all the values. Then D. D is nothing but unknown displacement. Theta B, theta C, theta D. Unknown displacement, which is equal to minus 300. So what are these? What are delta D? Minus 300, 0 and 200 means these are the external moments. These are the external moments. Sometimes in some problems there will be no external moments there. When there is no external moment, you can substitute 0, 0, 0. But here there are some external moments in the problem. See here. For this first coordinate there is external moment 100 into 3. Okay, this is anti-clockwise. So minus 100 into 3, minus 300. Here it is 100 into 2, 200 clockwise. So plus 200. There is no external moment here, so minus 300, 0, 200. Okay, so here we can find, by solving it we can find theta B, theta C and theta D values like this. Then step 6, using the slope deflection equations we can find MA, MAB, MBA, BC, MCD, final end moments. We can find the final end moments. So MBA is 300 kilonewton meter. So what about MAB? MAB is 0 because at A it is free end, so there is no moment at A. So MAB is 0. MBA, so to find MBA the formula is MBA equal to MFBA plus 2A by L into 2 theta B plus theta A minus 3 delta by L. So delta is taken as 0 everywhere here because there is no sinking here, no sinking for any support. Delta you need to take 0. So here you will get, if you solve it, all the values you know, if you solve it you will get 300. Similarly MBC you can calculate. Similarly MBC, MCB, MCD, MDC and MDE, everything you can calculate, and you can draw the bending moment diagram also after finding the final end moments.